Well, let me say actually just because we have a soft start anyway,
Yeah.
as folks are coming in, we have something for you to think about
Okay.
up on the screen.
Okay.
Because this is, this is a workshop on instructional routines for numeracy instruction, and where you may not know what all of that means, and that's okay, but we're gonna jump right in anyway, and trust us that that we'll clarify some of that language later. But for now, as you're coming in, as you're settling down with your settings and hopefully your lunch, um, take a look at the image on the screen, and I invite you to tell us in the chat, what fractions do you see? And not just what you see, but where you see it and how you identified it.
Sorry.
Oh. So I see 50% and 1/2. Eric, do you want to tell us where you're seeing that?
Sure. Oh, I lost my.
Go ahead. Go ahead.
Okay. The from the upper left point to the bottom right point bisects that square, and so then creates two larger triangles. So half and half of that square.
Okay. And so those two big triangles you're seeing are actually have other shapes inside them, right? You're
Yes.
identifying those large triangles. Astrid, I see
Yes.
you nodding. Lots of people are seeing those triangles as 1/2. Michelle, you said the little square in the big square looks like 1/4 to me.
Mhm.
Do you want to say either out loud or in the chat what's making it look like 1/4 to you?
So I'm just thinking like this, I wish I could show you what I'm pointing at, but the square inside on the top right side,
Mhm.
I felt like if I drew a line all the way to the bottom and followed the base of that small square to the left, that it would be 1/4.
Yeah, D, you have the screen share, right? Can you or maybe I found the annotate button. Hang on. So I think so you're thinking of maybe like extending these lines, right?
Yeah, that's
Is that what you were imagining? And then this square here
yes,
looks like 1/4 to you? Okay,
perfect. Yes.
great. All right, let me clear that away so that other people can I see somebody has Sarah, you said 1/16th. Where are you seeing 1/16th? And you can unmute or put your thoughts in the chat.
Sure. The little triangle, there are 3 little triangles, and each one of them is 1/16th. I'm basing that on being 1/4 of 1/4.
So maybe thinking about closing off this region here.
Mm-hmm.
And just like we said that this square over here was 1/4, you're thinking that this one also is 1/4, and you're seeing that broken into 4 equal parts.
Yes.
Thank you. Jen, we have 1/4 in both the large triangle at the bottom and in the square at the top right. So we've already looked at the square in the top right, but you're seeing this this triangle here is 1/4. And how do you know that that's 1/4?
Because there's another triangle on the left. And if you make more, it would be 1/4.
So you see one here also?
Flip it up. You would make one at the top and then make one on the right.
So you can kind of see that that's 1/4 because
There
you
you
can
go.
fill the whole shape with 4 copies of it. Yeah, great, thank you. Let's see. I see names of shapes too, squares, triangles, parallelograms. Are you seeing those as particular fractions? Um, and I'm sorry, I'm not sure. Is the comment says, is that sequential order of 1/2? I'm not sure I understand that comment. If you would care to elaborate, I'd love that. Somebody sees 1/6. So thank you so much for dropping them, dropping your fractions in the chat, but I really want to know, how are you seeing these? Okay, so the idea of the sequential order of 1/2 is that when we were talking about fourths, we started with dividing it in half and then dividing it in half again. Is that the idea? Okay, great, thank you. I mean, I see 1/6 and 1/8, and I haven't heard yet any explanations of where those where you're seeing those fractions. 1/8 is the bottom top right. 1/8 is the bottom top. Okay. Got it. Sorry. I had to work on my left and right for a minute, figure out, but I think, are you talking about this piece here that feels like it is the top part of the bottom of the right-hand side? Oh, look at all these awesome fractions coming in. 1/2 is the large triangle on the bottom left, cuts the whole square in half. Okay. The small triangles are 1/16 each. So we have a large group now, and there's lots of reasoning coming in. So I encourage you to be rigorous in your reasoning in your minds as well. I see sort of this building up from the small triangles to the larger triangles, building up things in 16ths. I'm sorry, I don't know how to say your name. Is it Samid? Please correct me if I'm wrong. It's but you're pointing out the when we're cutting regions in half, we're increasing the denominator. It starts at 2, and then when we cut that region in half, we get a denominator of 4 and then a denominator of 8. Sarah's pointing out that she sees 1/4 in both a square and a triangle. Can I unmute you? Let me see if I Dee, can
Unmute
you
yourself.
do that?
People are able to unmute themselves. Or they should be.
All right, this is I hope you get that sorted out, and I definitely want to hear from you, but also I want to jump in now that we've got a big group of people here. I want to jump into the formal start of the session. So and we'll come back to what's going on with this fraction diagram in a few minutes. Dee, can you go to the next slide? So, okay, so welcome. I really hope you're in the right place. This is Instructional Routines for Numeracy Instruction, presented by 3 of us who are here from the Adult Numeracy Network. My name is Sarah Lomberg-Liu. I'm from Massachusetts, and I work in professional development for numeracy teachers here. But there are 3 of us, so I'm gonna let Dee and Eric say hello. So Dee, do you want to introduce yourself?
Sure. Hi, I'm Dee Crescitelli, and I am joining you all today from Georgetown, Kentucky. I work with the Kentucky Center for Mathematics. I'm the president-elect for the Adult Numeracy Network, and I do a lot of work as a PLC coach for Kentucky adult education here. And I'm very glad to be here with y'all today.
Hi, everyone. My name is Eric Appleton. I'm the past president of the Adult Numeracy Network, and I work as a math professional developer for the CUNY Adult Literacy Program. CUNY is the City University of New York. And I'm excited to be here. I think I'm jumping into the introduction. Is that correct? Could you move to the next slide, Dee? So the Adult Numeracy Network, if you haven't heard of us before, we are the professional organization for math educators who work in adult education. And we have many members, and we invite members to join anyone who involves numeracy in their teaching. So we have many ESL teachers, people who teach ELA. It's not just math teachers, but we focus on math instruction for adults, especially adult literacy, GED classes, that kind of thing. And we really see ourselves as a community of teachers learning together. So we have members across the country and some members across the world as well. Well, we'll talk more about the resources we have at the end of the meeting, but this is where you can find us. We'll be putting our our website and information about joining and membership benefits and all that a little bit later. But for now, I'll give you all the website, and then we'll we can move on, Dee. So 30 years ago, when the Adult Numeracy Network was formed, none of us here today were part of the organization at that time, but our wise elders developed teaching and learning principles that which we still call upon to ground our instruction, and when we think about professional development, thinking about what is most important in our orientation. So these are a couple of the things, a couple items from our teaching and learning principles, that we believe that mathematics instruction should build on what students already know, valuing the various informal and alternative strategies students use to solve problems. And we believe in mathematics instruction should include opportunities for students to question, reason, solve problems, define goals, and monitor their own progress by using estimation, mental math, computation, and technology when appropriate. So today we're going to use these two principles as a frame for reflecting on the instructional routines that we're going to work on together. When we plan activities for our classrooms, we try to accomplish this vision of math instruction, one where students are building on prior knowledge, they're involved in discussion and questioning, problem solving, self-assessment, and making sense of problems, making sense of math in the real world. And we'll come back to some of these ideas later. And I think we can move to the next slide, Dee. And this is back to Sarah.
All right, thanks. So what we did at the beginning, when I asked you to look at that diagram that you can now see in the lower right-hand corner of the screen, that's called a fraction talk. So thank you so much for engaging with it. You've already now experienced an instructional routine, and as I said, we'll get more into what that means. But what we'll do now is sort of let you in on what's the teacher side of that activity, and it's pretty simple. The teacher side of the activity, the structure of the fraction talk, is to start with an image. So I shared an image with you, and then you can shade in part of the image, or you can just ask like an open question, like what fractions do you see? You can ask what fraction is shaded. The main thing is that you invite students to share not only their answers, but their reasoning. And you saw the kind of conversation, even in this, very sudden, you all popped into the Zoom and you don't know me, and we're interacting mostly through the chat, but still like a lot of rich fraction reasoning came out of it. And I started with the question, what fractions do you see? But there are lots of other questions you can ask. You want to drop those in, Dee? Okay, thank you for adding that comment. I'm sorry you're having difficulty with unmuting. Translation of word problems to the mathematical format of translates to multiplication. Oh, so that's that thinking about the going back to that fraction of a half of a half of a half has a connection to fraction multiplication. Yeah. So I'm going to come back to that in a minute to say. So let me just give some examples of some of the other kinds of questions you can ask with the fraction talk. Like I said, what fractions do you see? But I could also ask, can you shade exactly, and I could pick a fraction, like in what ways could you shade exactly half of this shape? In what ways could you shade exactly a fourth of this shape? You could see how something like that might elicit different kinds of thinking, different kinds of reasoning than that first open question. I could bring an area lens to it. You know, if the area of the shape is, and I could decide, and what number I choose to give you will affect what kind of thinking you have to do, right? If the area of the shape is 100, if the area of the shape is 1, if the area of the shape is 16, you can kind of imagine how your answers then to, you know, what is the area of the triangle in the at the bottom, how you might think differently depending on what area I give you. It could also ask you to color in the shape yourself in different colors and see what fractions emerge from that. So with a sort of a small investment in finding an image, and it can be a very small investment because there's a resource at the bottom right of the slide, which is fractiontalks.com, where there are many images already prepared for you, and all you have to do is pick one. You can generate really rich conversations, and based on your choices of what kinds of questions you ask or what directions you facilitate the discussion in, you can elicit different kinds of things, like, for example, connections between geometry and algebra, or making that connection of language of means multiply, right? Depending on who your students are, where they are, and what they bring to the conversation, and what choices you make, you might bring up all kinds of different things. So Fraction Talks, this is an example of an instructional routine. So let's go to the next slide so I can tell you a little bit about what we mean when we say instructional routines. So instructional routines are specific and repeatable designs for learning that support both the teacher and the student in the classroom, enabling all students to engage more fully in learning opportunities while building crucial mathematical thinking habits. So consider the richness of the conversation we just had when I just sprung it on you, and imagine instead that you're a student, and every time you come to class, or every other class, or every Wednesday, or whatever it is, you do a fraction talk. Right? So now you know how this works. You know what to expect. You know what kinds of thinking you're going to engage in. And that releases a lot of the tension that students can be carrying in math class, right? Where they don't know what's going to be asked of them. And it really allows the students to engage really deeply and freely and flexibly and comfortably with the content. And a well-designed instructional routine opens up conversations and thinking about mathematics that might not happen by themselves. And so again, there's benefits to the teacher in the sense that it's already planned, right? You have to work out the details, but the structure is there. And there's benefits to the student because there are no surprises here. And it creates space for these really rich conversations. So and I'll just I'll say, like, I love instructional routines. One of my favorites, which we're not doing today, but we'll send you to a resource where you can learn a lot about, or you can learn about a lot of different routines. But one of my favorites is a number talk, and it's got some things in common with a fraction talk. In that a lot of it is about talking about student reasoning, about getting student voices in the room, and celebrating the ways that students bring their own lens and their own way of thinking. And I did a lot of my teaching actually through number talks. And it's just share one quick story that one time, since we always did a number talk at the beginning of the class, we had settled in, and I had a student get up and start to walk out of the room. She was heading to the bathroom, and I said, okay, we're going to do the number talk now. And she turned around and came back and sat down and said, I'll go to the bathroom after the number talk. So just to say that that's the kind of joy that you can create with these instructional routines. So now I'm going to let Eric take us through another instructional routine. You'll get to see a few today.
Great, thank you, Sarah. And so we're gonna look at a routine called Would You Rather? And we can go to the next slide, Dee. So, would you rather have one of 8 slices of a 10-inch pizza or one of 10 slices from a 14-inch pizza. Now, you might have paper and pencil in front of you, and you might want to have paper and pencil or a pen later. But for a moment, before you write anything down, I'm curious to know what your gut response is. We're talking about pizza. So what do you think? Which would you rather have? Maybe we can have a couple answers in the chat before you've had a chance to really think about it too carefully. What's your gut response? Would you rather have one of 8 slices from a 10-inch pizza or one of 10 slices from a 14-inch pizza? I'm going to wait a moment to see a couple of the responses. So give us a quick response. One of 8 from a 10 or one of 10 from a 14? The 14-inch pizza is cut into 10 slices. The 10-inch pizza is cut into 8 slices. You only get 1 slice. So which pizza do you think you're going to want? Okay, so we have a few responses here. We have Sarah saying 1/8 seems like more. Renee saying 1/8. Sarah saying 1/8. And Johnson saying 1 of 10. Tamla Lois saying 1 out of 10. Okay, now what I'd like you to do now is take a few more minutes. It's good. We've got some controversy. I always love when there's sort of difference of opinion at the beginning or at any point in a math problem. So take a few minutes and think about it on your own. We'll give you a couple minutes here. So take a moment and maybe we'll kind of hold off in the chat, hold off and let you all think about it. So take a few minutes. Which would you rather have?
I like the fact that you're ecumenical about the topping here, that the topping is not part of the decision-making process.
It's true. Well, we do have some images here that are implying something, but yeah, I'm not. Yeah, it's true.
We had a separate conversation as we were building that about do the toppings matter?
Yeah, yeah.
Can I have the calzone?
Yeah,
The calzone in the back. Yeah, good point. Sorry, that wasn't part of the choice.
right. In some
So-
places, if you put the pineapple on it, this would have stopped the thing to a halt. So,
Especially in New Jersey, no,
Yeah,
right?
yeah.
Y'all are the-
Okay.
The
I'm
experts here.
I'm a Kentucky girl married to a New Yorker, and that's a thing. Yeah.
So let's see. Does anyone want to amend their answer? Are you going with the same answer you had previously? Let's see. Any new answers now that you've had a moment to think about it? If obviously we're with the class, it'd give you more time. We're on a little bit of a rush schedule, but curious. Anyone has the same answer they had before, a different answer? And feel free to unmute if you want to explain your reasoning. One thing you might think about is, well, do you want more pizza? Do you want less pizza? If you're trying to control your own impulses, maybe you want fewer slices in the pizza, or maybe you want more slices because you're less likely to eat more. Or maybe there are other considerations that you're thinking about. One question I have is, how different are the sizes of the two pizzas? How much bigger is a 14-inch pizza than a 10-inch pizza? Is there anyone here who would like to argue that 1 out of 8 is the choice that they would choose? It's better for them. How about anyone who would like to argue for 1 out of 10?
I won't argue, but initially it seems like 1 out of 8 is going to be a bigger portion, but no, because I think that 4-inch difference in the pizza makes a big deal. I mean, yeah, 14 inches to the 10 inches makes a big deal. And even though 1 out of 10 theoretically is smaller than 1 out of 8, but I think that 4 inches makes a big deal because a 10-inch pizza is a personal sized pie, and anybody can eat that.
Right, 1 out of 8 out of a 10-inch, which seems like that's sometimes a personal pie, right?
Yeah, yeah, that's so small. It's so small. So
And if-
because I like pizza and ice cream, I would choose the 1 out of 10 slices because I think it's going to be bigger. Anyway, because I like pizza without
if-
pepperoni. Without pepperoni.
Thank you, Richelieu. Wait, so a 14-inch, is that just from personal experience? Is that that's like a large pizza? Is that the largest you get, or there's sometimes they're bigger?
Sometimes they're bigger, 8, even up to 18. Look at Costco's pizza. You all have Costco where you live, right? Look at
Ah.
Costco's pizza, for example. But anyway, I would admit that I could eat a regular pizza that's cut into 8 slices. I guess that's what, 16 inches diameter. I can eat half of that with no problem. That's how I maintain my shape.
Thank you, Richelieu.
TMI. But anyway, I would choose 1 out of 10.
Cool. Thank you very much. Well, there's a lot of reasoning that's happening in the chat. The discussion of the area of a circle and then dividing by the number of pieces. Thank you, Suzanne. Dee, let's look at the next slide. We have an image from the website Polypad, which is a really useful tool for teaching math. I'll put a link in the chat in a moment. I'm wondering if seeing this image, the image of these two circles, changes or maybe reinforces your answer. Can anyone talk from these images? Is there anything you would say?
I think I'm reinforced
Say a little bit more about that, Richelieu, and why.
because the ruler shows for the smaller pie 5 inches, basically a slice, and the larger pie 7 inches.
What? And
So
which slice is bigger? Just from like if you're eyeballing it?
I'm looking at the length of the slice.
Ah, the
Not the-
length of the slice.
Yeah, from the edge of the pie to the center.
So you're seeing the green one, the 14-inch pie has a longer slice.
Yeah. Mm-hmm.
And for you, that means it's a bigger slice.
Yes, because the way my glasses are making me look, that the outside of the pie, the way the crust is, looks even larger on the 14-inch pie than the 8-inch slice. So my looking at it is that not only is the green pie longer, it's wider. But I could be wrong, obviously, but don't tell me.
You're looking at the length of the slice and then also sort of the
Yep, the
width
crust.
kind of along the crust along the edge of
Yep.
the circle, right?
Please, somebody else, please speak.
Thank you, Richelieu. And Sarah writes, thanks to the math teachers nearby who gave me the area formula, 25 divided by 8 versus 49 divided by 10. So 25, I'm assuming that is from 5 squared, divided by 8, and then 49, I guess, would be 7 squared divided by 10. And for Sarah, that's enough information to choose 1 out of 10. Cool. Let's
Can
go
I have
on.
input on this?
Oh, go ahead,
I'm not
please, go
sure
ahead.
if I'm correct. So I was looking at both of the pies. And the smaller pie, if the diameter is 10, that means that the radius would be 5. So 3.14 times 5 squared will give you 78.5. If you divide that into 8, you get a smaller number. And if you had, for the other one, the ruler stops at 11, but it's supposed to go all the way over for 14. And then 3.14 times 7 squared will give you 156.86. So I'm thinking that's why the slice would be bigger for the pie that is 14 inches.
Thank you. Thank you for that. Yeah, thank you for that explanation. Cool. So let's skip forward a little bit, Dee, if we can look at that. So we're just going to talk about the routine. This is a fairly simple routine. You can go one more. Thank you. Basically, it's every time you use it, you're basically asking the same question. Would you rather one or the other? Basically, a choice between two options. and then you're asking students to justify their answers. And we could have spent a little bit, we could have gone farther and actually done some work calculating, you know, visually calculating the area of each of those circles, dividing by the number of slices. It's up to you on how far you would want to go with that, but the focus is on asking students to come up with an argument and then critique each other's reasoning. So ideally, these questions are prompting discussion and debate among students. But it's not necessarily only mathematical information that might be involved. There might be other kinds of considerations that people would come up with to justify their choice. I mean, given the pizza option, you can say, well, I'm not very hungry, so I want less pizza, right? So it's not necessarily that one answer is right. It depends on the argument, really. And so the goal is have students critique each other's reasoning. This is one of the standards of mathematical practice from the Common Core, that students should be able to construct viable arguments and critique the reasoning of others. So this is an opportunity for us to do that. As shown here, this is another example. There's a website from this math teacher, John Stevens. He published a website with a ton of different examples. This one here on the screen of the piggy bank is, would you rather have $1.50 for every month of your life, or a nickel for every day of your life? So it's just a different situation. It's always two choices, and you have to choose one and then argue why you think that's correct. And I think we can move on, Dee.
Eric, excuse me,
Yeah.
would you, is just math stuff with numbers?
Oh, that's a good question. Off the top of my head, I don't know. I can totally imagine that we're working with things that are not mathematical. Dee or Sarah, do you know of examples of that?
I think the bulk of what John built here is, but they are not all, and other people have done riffs on this and have gone into, I mean, many of them are financial because it's really good financial literacy in some ways. But folks have done them with some other, like, let's just have some discussions and get at people's reasoning for different kinds of things. But because math lives in so much of that decision making anyway, there's usually a little tiny bit of element of math in that anyway. Yeah.
Thank you. Thank
But
you.
that's a very good question.
But also to say that the question in the routine is, would you rather, right? Which is not an inherently mathematical question. It's a question that involves mathematical thinking, but it would have been really different if Eric had said, which pizza slice is bigger? So one of the things that's really valuable about this routine is that it does open up space for mathematical arguments and for non-mathematical arguments and for other considerations like Eric was talking about, because when students use math in the real world, it's not so neat as, I mean, you could also say, for example, an argument that didn't come up, I'd rather have a slice of the smaller pizza because the smaller pizza was probably cheaper, right? Like there's a consideration that could be part of it. So it creates space for students to really bring their whole selves and all of their reasoning, which is what we want them to do everywhere in math class. And this is a way of opening that up.
Following that idea about maybe that smaller pizza is cheaper, this also allows for students themselves to pose questions that they don't necessarily have answers to, right? So, you know, I'm thinking, like, if I'm in the grocery store and I see one of these ginormo, you know, laundry detergents and a smaller one, oftentimes I think on purpose, the grocery store will use different units per price unit, right? And so you're like, oh, this is a quart, this is a gallon, like, what am I getting a better deal or not? And so a student can come in and honestly ask the question, like, all right, would you rather have this laundry detergent or this laundry detergent, right? And then they in the class can kind of work it out, you know, as a real world problem that they're dealing with.
Very good.
I mean, another one these days, if you ever go in and see the paper towels, 24 rolls equals 52 rolls, you know, all that kind of jargon, you know.
Yes. The paper math. Yeah. We have a
Yes.
whole series of things about the different kinds of toilet paper and paper towel math. Yep.
Yeah.
Right.
Pretty
And one will
amazing.
be per count and one will be weight. And you're like,
Exactly.
well,
Yeah.
I'm not supposed to compare these things.
That's amazing real life math to get at the would you rather. Yep. Yep. So we're going to move on to a different routine, and this one's called always, sometimes, and never. Okay. So what you're going to do is I'm going to give you a series of statements. You're going to decide if that thing is always true, or sometimes true, or never true. Feel free to type your thoughts on these in the chat, and then I may ask you for some more deep thinking about your reasoning to share that with us. So the first statement is 1/3 is one of 3 pieces. Is that always, sometimes, or never true? Someone be brave and unmute for me some reasoning before your sometimes. So we've added, I see some folks have added qualifiers, if equal sizes.
If you have a class of 27 students and you get 1/3 of the class, you have 9 students. You don't have 3 pieces, you have 9 students. Is that right? 1/3 of 27, yes.
Yes. Brilliant. Brilliant. So 1/3 doesn't necessarily mean I've partitioned something into 3 pieces. Right? We're looking at numbers of people. So 1/3 of a class can be, you know, it's not necessarily a piece in the same way. That's one of those things where fractions, paying attention to pieces versus parts and all the complication things that go with that, right? And so you get the idea of 1/3 is one of 3 pieces, as always, sometimes never. Folks have justified one of 3 equal pieces. Several of you wrote this in the chat. One of 3 equal pieces. If I'd added that one word, right, that might have changed the tenor of the statement. Let's look at another one. Quick reminder of this. I'm going to ask you to defend your choice. You guys have done a great job of that so far. And then we're going to look for examples and counter examples. And that was a reminder, but you guys are already doing it. So you didn't even need me to give you those parameters. So the next statement, dividing a number by 1/2 makes it smaller. Ooh, this is one of those. Now we have a math argument going. So I've got always and never. 2 ends of the continuum there. Always and never. And no, all in caps. No. We feel very strongly. Suzanne feels very strongly about that. So do I have brave folks that want to share some more justification? And now we've got to sometimes. So we have all of them. We have all 3 choices now. Those are my favorite. So do we have folks that want to give some justification for their choice? So somebody has given us 3 divided by 1/2 equals 6. So that is a counter example, which means it can't be always. All right, so we've established it can't be always. So now we're left with, is it sometimes true, or I mean, they made it never true. So is it always? Yeah, got it back. I just said it backwards. Yep. Depends on what you are looking for. Jonathan, tell me more.
I unmuted. So
Thank you.
Yeah, basically, you could divide it by half a number if you're looking for smaller, but also you might just be looking to cut things up by the total half. Take that pizza for example. You want to hand it to each student, so therefore you have the total amount. You just want to break it out. That's all. You're not looking necessarily to say, well, and to make each one smaller. You're just looking to make sure that you have the half part. But at the same time, you might be looking to make it smaller, or so it just depends on what your outcome is, what you're shooting for.
The purpose of the partitioning.
purpose of
In
it,
this case,
exactly.
I'm dividing something by 1/2.
That's
Right.
what makes it 2. Duh. I'm saying to myself, duh, makes it 2. I'm thinking of a cookie. 2 kids, 1 cookie. Dividing
But
whole
I
screen.
get that,
This is now.
but
Yeah,
also you still have the half. So it
Yeah.
depends what what you're looking for, what your outcome should be.
So Suzanne's taking us to a context, right? If I'm looking at a
Yeah.
set of things, right? That's a different perspective when we use those. If I cut something in half, I'm actually dividing it by 2. I'm
Right.
dividing by 1/2, as Richland said, we're spinning that sort of on its head,
That's
right?
true.
Yeah. So have
I
we
did-
come
I-
to a consensus on an answer or no?
Yeah, I didn't read the question. It says dividing a number. It doesn't say dividing a cookie. And like that, the other participant said, dividing a number means timesing it by 2. Hello, that doesn't make the number smaller.
Any more examples or counter examples? Does it matter if my number is positive or negative?
Hmm. I think so. I think so.
So we've done the divide 6 by 1/2 and got 3. What happens if I am dividing -6 by 1/2? Does that change that?
And a negative.
Well, you're dividing 6 by 1/2. You're not dividing 6 by 2.
Right, but if I divide -6 by 1/2, what do I get?
-3. So that's a larger number.
So it did still make it larger,
Yeah.
right? Just wanted us to posit that thought, right? Because, right, so what did we ultimately decide? Always, sometimes, never. Does it make a number smaller?
Kathy, are you speaking? I see your mouth moving, but it looks like you're muted.
Thank you, Sarah, because I didn't see her. Yeah, she's not in I can only see so many folks. Thank you for catching that.
What happens if it's a decimal and you divide it in half or divide it by 1/2?
Yeah. So 1/2 divided by 1/2, right? 0.5 divided by 1/2. So some people are going to sometimes now that weren't at sometimes before. Lots of sometimes happening now. So -6 divided by 1/2, I've gotten -3 and -12 as my answers, right? Isn't this great? Isn't this great? Right? So we feel good about landing on sometimes because we've got some different places that we have gone, right? Feeling good about that now. Yay. I love it. How much math have you guys already done in this session today? This is great. Let's look at one more. If two fractions have the same denominator, the one with the largest numerator is greater. Krishna, I love how you put the post in and then you sort of look like, let's see if other people agree with me. You are going
Yeah,
on. I love it.
I'm not a math I have to teach math on my job, but I didn't major in math. I only took 3 years in high school, but I've been teaching GED math most of my career, besides English as a second language, and based on just what I learned in high school, in a Catholic high school last century. So I don't have the theory and all that stuff behind me, but
That
yeah,
is
that's
true
fun.
for lots and lots of adult educators, though. So you are in good company here. So I've got some always and some sometimes. Love it. Do I have some justification, some defense, and some examples for this last one? Suzanne's reminding us to consider negatives. Does that matter here?
I think so. I don't know.
So Renee's got a thought. So if we're talking just positive integers, right? If I just say, if I give this as an assignment to third graders, fourth graders, think in public school, right? That's a fair statement to say that's always true. But the minute we go below 0, right? I can have two fractions with the same denominator. Let's just do thirds, right? And so we have 1/3 and 2/3. 2/3 is greater than 1/3. But if I have negative 2/3 and a positive 1/3, right? There gives me the sometimes. And so sometimes it's thinking about these things in
Context.
reference to the context, right? But also the mathematics that you are teaching. And I call it the rules that expire, right? So if I give this as a rule to third graders, they get to middle school and that falls apart for them. In adult education, we definitely can't give rules that expire because the whole map of mathematics is available, right, to them. We have to be careful about that. So this routine forces us to think about that. There's another whole slide of these that we're not going to get to today because you guys ask good questions. But these are available when you get the PDF of the slides. There's 3 more of these things for us to share with you guys. But the overview for sometimes, always, sometimes, and never is it gives you lots of rich things to talk about and have math arguments about, the best kind of math arguments. And Dana, we purposely did not really give you an answer sheet because the discussion is really the point, right? Because all you have to do is come up with counter examples and then you answer the question, right? All you have to do is come up with one that gives you some idea of, oh, this is what it has to be, right? The exploration of it is really the point. But the point is to provide an opportunity for students to test statements to see how far they are true, right? To actually do that testing of the statement, to provide examples or counter examples to support their conclusions. We want folks to be able to justify, share their thinking, but also be able to justify it, right? And have discussions and good math disagreements, right? And come to some conclusions as we get to them. And then he practiced providing convincing arguments to support those conclusions. They actually really think deeply about the math, and you guys did too, right? In the context of doing this. So, any other questions about that? All right.
So we're curious to hear, we've heard from a lot of people already, but we'd like to hear a little reflection on what we've shared. We've shared 3 different routines, the fraction talk that Sarah shared at the beginning, which would you rather with the 2 pizza pies, and always, sometimes, never. But we're curious to know, how might you use some of these routines in your classes? You could answer in the chat, or you could unmute, whichever you like. Samadeni says fractions have to be visualized to understand. So I'm assuming that it means that the fraction talk routine might be useful in giving, because it's always proceeding from some visual. Yeah, I'm sorry, we don't have the ability. I mean, hopefully you can unmute yourself, but everyone that should have the ability to unmute themselves. Renee says, as a warm-up to get them thinking, I think, yeah, these activities work really nicely as a warm-up. It's nice to have something that the class begins with. I think we used it in this session. We used the fraction talk as a way to engage people who are here a few minutes early, and often these activities will extend so that even if you find one answer, there are many other answers. So it's not like you do one answer and then you're done. There are many different possible answers, which means that it works at different levels, and it also works over a bit of time if people are kind of coming in slowly to class. Other ideas on how you might go ahead, Eric? Sorry.
Yeah, I have a friend who's a math teacher, and one of the routines that he really likes, or games that he really likes, is like there's 100 pennies, and you can either take 1 penny or 2 pennies, right? And the idea is that at the end, you want to force your opponent to take like the last 2 pennies or whatever, and then students would be like, "Whoa, strategy doesn't matter until the last 5 pennies." They're like, no, strategy starts in the beginning. But so looking at that pizza, and particularly looking at that trapezoid, which I think is a 5/16 slice of the pizza there on the left, like I can imagine like carving out different slices of pizza such that your classmates would be left with like a fraction that they could not calculate. Like you would win if you left your classmate with a piece of pizza that they'd be like, I have no idea what this is. Right. And so you have to think strategically to cut the pizza up to put somebody else at odds.
If you had a square pizza that was cut in this crazy fraction talk way, and each person chooses a slice one at a time or something. Yeah, that's a cool idea.
Yeah.
Love the smush in the routines right there.
Smush them together.
I wanted to add a thought too quickly, just to say that when we chose these 3 routines, we focused all of them on fractions, but with the exception of the fraction talk, these routines can be used for other topics as well. So we wanted to give you sort of a rich fraction experience, but I want to encourage you to consider, especially if you check out where these routines came from, that they're not all about fractions. You can use these with lots of different concepts.
Dee, could you reveal the next question? So the question is, how might these routines connect to math you are currently teaching? So do you see any opportunities to connect to the kinds of math you're already doing with your students? Where you might modify these routines to do something you're already doing? And we might have you continue to think about that. We can keep sharing in the chat. Give you just another moment and then we'll start to share resources, but we'll also have opportunities to talk and discuss along as we start to close.
Oh, we're adding new, we're adding new things, right? Always, sometimes, never. It's awesome. Awesome. Thanks, Jen. So let's talk about some resources. So the Adult Numeracy Network has collected instructional routines that are accessible and challenging to all students. We shared 3 of those with you today. They're about presenting problems before offering the explanation, so they give folks an opportunity to work through them. They can be approached in multiple ways using different types of sense-making strategies. So students coming from all sorts of different backgrounds and levels of already understanding mathematics have ways in to do them. They promote understanding through discussion. Sometimes the discussion is the main point, right? Sometimes we are working towards a solution and sometimes there's more than one, right? And they make student thinking visible so that you know what your students really are thinking and doing with the mathematics. And they make the math visual, which has come up several times in the chat and over the course of these discussions. And they encourage the practice of mental math, right? Anytime we can do something mentally, it ups our speed. And ultimately, sometimes that's important. That's not the most important thing in mathematics, right? But being able to get rid of some of that mental weight of being able to do some things in our head makes us feel more confident about the math as well. And so these all live on the Adult Numeracy website in a lovely, I don't know if you're putting it in or if I am, Eric, I'm working on it.
I can do it.
Okay.
Sorry.
I got waylaid because someone had sent me a message just to me and I didn't catch that. And so I was in the middle of putting it in and it was going to just one person. Thanks, Eric. And so there are 28 of them collected as of this moment today, but we keep collecting them as they go. They're really different from each other, the different ones on this website, but they all fit the criteria. And they give you all sorts of amazing resources to get started. Open that tab and save it for later. We're not going to have time to go look at it today, but save that for yourselves and use some of those amazing things that you have available to you there. We love it. And if you have ideas of other ones we don't know about, share them with us, send them to us. We'll add them to that. And then we referenced at the beginning, Eric talked a little bit about who we were at the Adult Numeracy Network. We are a resource for all adults teaching other adults mathematics, right? And so we have teaching resources. There's a lovely calendar of events, a newsletter. We give grants for teachers and share practitioner research about what it means for math education for adult learners, which is different research than some other folks. And Jen, yay for the Math Equals Love. We love them. So yeah, she's doing some of the resources that some of those live in on. We've linked to some of those friends too. So I'm glad you guys are discovering cool things. Some of the things on the Adult Numeracy Network are available to everything, and some things are only available for you as members. And we would like to basically encourage you guys to become members. If you're someone who teaches math, we're a nice, inexpensive date for really good support for teaching mathematics and just having someone to talk to who does the same work that you do, right? Because it's different teaching adults. So that was my pitch for that. Other questions? You guys have put all sorts of amazing stuff in the chat that I'm going to go back and catch up on now.
All right, and as you're looking over their questions, I have dropped in the chat the link for those of you that need the professional development certificate for this session. Please fill out that form and I'll send it to you after the conference is over. And I just want to thank, all of our colleagues at the Adult Numeracy Network for always answering the call when I reach out to get some numeracy content at the conference. I think it's really essential that we don't silo and marginalize folks that do different sorts of work, because we all work with adults. And in some ways, disciplinary differences are just arbitrary, right? And that we all work on these things at the same time. I mean, how do you really differentiate language from math, right? The language that you were talking about learning, that's part of learning math, and vice versa, right? So I think the more we can meet together and talk, the better. All right, I want to thank everybody that came to this session, and thanks for sharing your ideas, and also rolling up your sleeves and diving into mixed two metaphors. So it's always nice to get the turnout that way too.